All right, welcome to Vegas Programmers. Thanks for everybody that came out. Happy New Year to everybody, 2025. I know I've got a lot of plans. I hope you do too. And I wish all the best of luck to you in this new year. So, with the whole new year, we've got a awesome treat, which is Adam Englander last month gave a talk, and he's been delving into AI. I know I kind of did some AI talks too, and I love to kind of hear other AI talks just because it's a hot topic right now, right? So tonight we've got AI and the SDLC DevOps Conundrum. So you're going to be doing this talk at Confu in Canada, right? Which is super exciting, and he's kind of just trying to get some feedback. So while you're listening, if you see little spots that you think either you have questions about or you think are factually incorrect, I'm joking. This is the opportunity. This is why we give talks before we do them at conferences, because we want feedback. So thank you, Adam, for coming back. And he's kind of the OG PHP Vegas founders, actually. There's a long lore that I won't really go into right now of like all of it, but this group has been around for quite some time, and he was one of the people that resurrected it and then kind of voluntold me to help organize it, and I've been running it since, and now he's back, so it's awesome to kind of get that feeling back in the group. So I've got a couple of things at the end too. I've got a JetBrains license to give away for any free IDE, as well as a 1-month subscription to Symphony Casts, which is basically Symphony Framework, which is an awesome framework. And Symphony Cast is great. And Ryan Weaver, who makes all of those, is awesome. He's going through a lot right now. If you could, go to his GoFundMe and contribute some to his brain cancer that he's dealing with. That would be greatly appreciated. It's been a rough couple of years with him. And I know Symphony Con is happening in Chicago here coming up in I think in March. So if that's kind of up your alley of what you are doing, definitely check that out on live.symphony.com. And there's a bunch of other conferences happening here soon. There's Longhorn has not been announced yet, but I hear through the grapevine that is happening. And just what's? Oh yeah, okay. So you already kind of heard. And then check out Merge PHP. So I think I've failed to kind of say this, but I also help run a monthly online PHP meetup called Merge PHP. And every month we do an online talk from many of the user groups that are here in not only the United States, but we're trying to get some others around the world. So check that out if you're interested in PHP. And without further ado, I guess let's kick it off. Yeah?
Cool, thanks. Tech's in Chicago too.
Yeah.
PHP Tech.
I'm sure I missed a couple. Yeah.
Oh yeah, there's conference all over the place. Hey everybody, I'm Adam Englander. Here to talk about AI and the SDLC, which is software development lifecycle. For those of you who don't know, DevOps Conundrum. I work at an AI place. I'm a CTO at a company that does AI for insurance companies. And so all of this is basically, I'm not an AI guy. I'm also not a DevOps guy. I do some, right? I think the whole thing of DevOps, right, is developers doing ops. That could be a nightmare. I'm not an AI expert, but I have learned enough to be able to build an app and get people to use it and pay for it. So if you don't know it, AI is coming. If your company doesn't have an AI plan, they almost surely will. Unfortunately, most of the time, it's the CTO is told, figure out our AI plan. And if you're a software developer, that rarely goes well. And if you're a developer, it's going to be your problem, right? Invariably, whatever solution they pick will be, you're going to have to change your app to use external AI stuff or have to learn more about something having to do with AI. We're not going to get into what Josh got into, which is like how to use AI for your software development. This is more for adding AI to existing applications to do things that you either may not do or do things that you're doing better. So the conundrum, right, comes from significant changes. And those significant changes are shifting of responsibility. So it's primarily why this exists. And to understand the shifting, right, let's talk about something that a lot of us are familiar with. So also, this, if you were here last month, some of this is going to look very familiar because it's pretty much the same. So 10 years ago, at least for me it was 10 years ago, we saw ops shift to the right. There was talk about it, and really cool people were doing chef and puppet, and that was more, you had systems people that were automating, right, and orchestrating that stuff. But I would say for me, it was 10 years ago, developers started being in charge of that. Most of my career, right, ops and dev were silos. We talked to each other, but ops people had the servers, they had the servers running, they built them, operating system, your runtime, and applications were just, we're going to give you the code, you may have a path to deliver it. All right, I never, at that time, DBAs messed with databases, developers didn't touch databases. We might discuss them, and we might confer with them about, hey, I need this new library installed, or I need a plugin installed, or I need this version, but it was up to them to decide whether we could have it, and up to them to make sure it happened. And then that changed, right? I assume most of us have something to do with something going in there, right? Is there anyone that doesn't do any sort of containerized development? Okay, so you get it. That was how they shifted the operating system to the developers. Oh, it's container now. It's your problem. And the runtime, it's your problem. And the installed libraries, it's your problem. And so, right, there are things that either got duplicated because they still have to manage operating systems at some point, right? If you're a developer, if it's on the cloud, it's probably through some orchestration system that you don't have to manage, hopefully, but you may be. But a lot of the things that you never did before as a developer, now you had to do. And it provided better control for developers, but there's a lot of stuff you had to learn, right? You had to learn specific pieces of the stack, which I'm still terrible at operating systems, but I can make it work, right? But there's a cost, right? Is you have to learn all this new stuff. It's pretty common now, right? When this first started out, you're like, oh, I've got to not only do I have to figure out this orchestration stuff, I've got to figure out operating systems, how to get stuff installed, how to do it right, how to make it secure. It was a lot of learning for me, but this was a fairly groundbreaking disruption, right? I remember coming to meetups when people were talking about containers and bare metal is dead, and I'm like, you're insane. And I don't know anybody doing bare metal anymore. So the other thing that came is we started using more services, which are platform as a service, right? So whether it's AWS or Azure or Google Cloud, you're probably using something somewhere. And if not, you probably will be. But all those things, as developers, right, gave us an immense amount of power. I don't have to manage hardware. I don't have to purchase things. I don't have to know what bus speed I need or what CPU I've got to have or how much memory, right? I can just go to AWS or Azure or Google Cloud and provision something and get it up, and I can have the database there and do all the stuff I got to do. So it allowed us to build applications at scale for better or worse, not knowing much about what's going on in the back. And what's happening in AI is that's happening with data science. Has anyone here ever worked with a data science group or professional? Okay. Those are very special people. Well, if you've worked with good ones, right? The ones I worked with, I think, were Most were PhDs. Some of them only had their masters. But they were very specialized in certain types of mathematics, and they were especially specialized in data science. And what I've known for most of my life, right, is that data science and dev are separate, right? They build the models, we use the models. We don't even have to know how to use the models. They just say, here's the interface. You send us these characteristics, and the model will just do whatever it does. And data science was responsible for making sure that it worked, right? So when you're using a model, if you had a data science team, you know that you have to be, they're constantly telling you, I need data to verify the model's working properly. If you don't, that's what they do. Because they build a model, they have training data they think is, yep, this is probably what's going to be, but they've got to constantly look at it and say, okay, is it still performing well? Is it still performing well? That was their job. And now there's models as a service, and that's what I use. And if you're doing AI moving forward, that's what you're using too. Unless, again, you have an entire data science team. But what you're probably using is large language models. So it's still going to shift anyway. So there's a bunch of new things that you're going to have to learn, right? And with the advent of fine-tuning, you can start with enormously complex models and fine-tune them for application-specific usage. So we're not going to talk about fine-tuning, right? Fine-tuning is a whole another world that has a whole another cycle that is not application development. But it's entirely possible that you will be, as a developer, you may have to find ways to do fine-tuning. Because I know my plan is I'm going to get as far as I can get without requiring a team of data scientists. Because data scientists are expensive because they have PhDs, and they're really, really high in demand right now. So I want to try and do as much as I can before I get to the point where my performance requires that I get a professional. But I want to remove it from the list, so we're not going to talk about it. But there's this, like, the solution, right, for all of, there we go. Majority of the presentation is a solution, right? Problem being that you're going to have all these responsibilities, right? In DevOps, now you've got to deal with a bunch of other stuff. And if you haven't been in it before, it's like I was talking with someone earlier. It's like, you don't think about the fact that, like, AI does stuff differently, and you have to have these different skills to do things. And it's the same problem. And again, there are probably other solutions, but this is what I've found to be the solution. From building, I worked at a place, I worked at TransUnion, where they had a lot of data science. And they had models that they had to deploy, which is kind of old school ML, right? Machine learning, to today where I have a product that's everything about it is AI, which is using large language models. So the DevOps revolution, right? It didn't change how we built code. Right? It changed how we automated and pulled in ops processes. So code is still code. And it doesn't change with AI either, right? You still, you're going to have to some extent, right? In planning, you're going to need to include some of the things that you're used to doing, right, with the old DevOps process. So that's going to be, releasing, configuration, and monitoring. Creation included creation of infrastructure, right? Infrastructure is code for managing packages and releases, configuration, that type of stuff. And when we went to DevOps, right, verification, right, was now automated, right? If you're doing a part of this, like before DevOps, I had somebody who managed the servers, and then I would say, here's the new code for the servers, or we would have some automated script in a place that would allow us to go to deploy the code. And then we had QA people who would then go test it. And then we'd say it's good or bad, and we'd roll it back, or we keep it. Today, that all happens through automation for me, right? It's like I merge something in, it automatically shoots it over to a QA place where we can do manual stuff if we need to. My business owners can verify. It's running hundreds of automated tests to make sure everything still works the same way. And then when we're all good and we're at a release window, I just hit release, automatically pushes it out, tests it all, right? So all that's automated for me now. And again, the packaging part, right, that used to just be like, here's a tarball, or here's a jar, or a war, or an ear, or a binary, whatever your programming language is. Here's a mobile application file. But now, at least on the web dev side, right, is you're including an operating system. You're including all the things that go with it. And it's doing all the chores like updating the database, right? That was the big DevOps ship, is it's doing all those things. Creating network file stores, right? Stuff like that. And so now we're responsible for configuring applications. We talked about that a little bit. I'm probably getting a little duplicative here. And we've got monitoring, right? Hopefully you've got monitoring. I know I have monitoring. To let me know that things aren't going well. And that's that's what wakes me up in the middle of the night, with the phone going completely crazy when something went wrong. Because my pager duty just got alerted. So the AI revolution is disrupting developer responsibilities, like we talked about. Right? It's also developing it in the DevOps cycle, on both the dev and the ops side. Right? So if you look at the standard software development lifecycle path, right? Everything starts with I gather requirements, I come up with a design, I implement the design, I test it, and then I evolve again, right? That's the application development lifecycle. Machine learning is a little bit different, although similar, right? So problem definition, data collection and prep, designing the model, evaluate the model, develop the model, and then monitoring and maintenance. And we won't be deploying models, right, if we're just model as a service. But we will be doing requirement analysis, right? And so requirement analysis and problem definitions and planning, they're pretty analogous. So it'll be stuff that you're pretty used to. Designing the model actually encompasses design and implementation, right, in the software development lifecycle. Evaluating the model is like testing. And SDLC, right, will be covered by model deployment, monitoring, maintenance, but we don't deploy. We're not talking about deploying models. Again, that's a whole other thing. But monitoring and maintenance, right, are still part of the new evolution. Right? So we've pretty much mapped out the similarities, right? All the check marks are accounted for. So the whole left is accounted for, but there's still stuff left on the right. And that's a bit of the problem. So that's the part we need to talk about, the differences. Because as we're building and deploying applications based on AI models, we'll have to modify how we execute every one of the check steps. And again, these will probably be obvious, right? You have to change the code you write because you're consuming a model. You have to change your deployment, your configuration, right? You'll have to design is a little bit different, right? The things that you're used to, those are really fairly obvious. Those are more of the dev than the ops side. And you can mostly consider the AI model you're using as an external service. So because it's AI as a service. So it's not like you've got to add new monitoring to make sure it's up and running. You're not necessarily worried about its response time so much because you're not responsible for that, right? If I'm using S3, I'm not monitoring what the latency times are for S3 and response times. I'm just using S3. And models as a service are basically the same thing. But the unchecked parts are where the conundrum exists. They require the data science skills we discussed before. Some will map kind of obviously, and others will not. So if we remove prompting and model usage from the gap, as I said, model usage is like any other service. And any other prompting and model usage is an entirely different presentation, right? So if you want to get into doing all that, that's going to be a lot. That's another talk I gave Saturday on how to do model prompting. But again, it's also fairly obvious what you need. So let's talk about the remaining three. Performance testing and monitoring might be familiar to you in your cycle, right? Hold on, let me go back to data gathering for a second. Yep, I left out a slide. So data gathering is probably something you're not familiar with doing, right? It is absolutely going to be part, if you're doing AI applications, it's going to be part of your development process. It's part of your planning, right? I'm going to build something that uses AI. What are we expecting from the AI? You're going to be doing prompt engineering and sending requests to the AI. And how do I know it's giving me back the right answers, right? It's not like an external service where if I give you this, you give me that. With AI, like we talked about last month, right? If I give you this, you'll give me something back that may or may not reflect what I'm expecting. And I may give you one answer one time and a different answer the next time and a different answer the next time. And they may be there'll be different varying levels of correct. But the only way that you will know if it's correct is by saying, here is what I put in and here is what I expect out. That data has to exist. You can then say, like, how close is the response you gave me to what I'm expecting? Or you may be able to say, here are the pieces of this output that I care about and here's what it needs to be, but that's still data, right? These are data points you've never had to deal with before because someone said, when I click on here and I click on this, then it shows that. And it will always show that because we work in very, very consistent programming languages, most of us, where I have hundreds of behavior tests that it only checks to see one value, like true or false, right? It's not, oh, well, I did this 100 times and 99 times it passed, which is acceptable, right? That's actually more like on the level of performance testing that a lot of us are used to. But without the data, you can't do anything. You have to know what is in, what is out, and if it's a large enough application, that could be a lot, right? And it may exist or you may have to synthesize it. So performance testing and monitoring is familiar, right? But there's significant changes to what's needed. I just talked about, okay, I did have data gathering here, so I was there. My bad. I'm gonna have to go fix those. Just finished this weekend. So critical success. Right, but again, like the data thing, you're not building models. We said there'd be no model development, but you need to be able to do it for testing expectations, right? So if we look back at the initial cycle, data collection preparation are in step 2 of the ML lifecycle, right? It's like, what's my problem? Then I have to do all the data. It's going to be the same because it affects design and prompting, evaluates effectiveness of the implementation. Again, I'm not going to dive deep into it because that's really, it's dependent based on your AI design, right? If you're building a help system, you're going to have one way you want to check it if you've got like an automated chatbot. If you're building something that's going to look at something on an image, let's say in the insurance world, you're going to take a picture of something and it's going to determine that, oh, that is a Sony Bravia from 2012, here's its current value. You have a whole different thing that you're going to have to test, right? And how you're going to do that and the data you collect is going to be different. But just know that you're going to have to collect it. But again, off topic, but the most important thing is that you'll need to skill up in data collection, right? That's something that, you know, I was a DBA in a past life, so I know data. I did ETL back when no one knew ETL was. So I thought I understood this stuff, and then I realized, oh, this AI thing, it's the same data I had to capture for data scientists. All right, here's in, here's out. Even though you're not training models, you're not evaluating models, you're still evaluating how well that your prompt works and all that type of stuff. Any questions so far? I'm going really fast, and I think I'm a little jumbled. Yeah.
Is your presentation taking into consideration the Cosmos framework from NVIDIA and its synthetic data generation?
Well, so synthetic generation, data generation is one way to make it. So I said we're not going to get into how you're going to make data and where you're going to collect the data, because that depends. Because some data can be synthesized and some is not as easy. Because you're like, if the evaluation is I evaluate this photo and I correctly identify the television and how much it's worth, that's a whole different thing from I am summarizing the reviews inside of a product. All right, so what data you have to gather is going to be very different, and the tools you're going to be able to use to generate and synthesize. And sometimes synthetic data is good, sometimes it's not great. And there's also different levels of synthetic data. Not necessarily for this talk, I've got another talk, but basically my experience is that synthetic data can get you into problems when it's not analogous enough to what you're trying to train. Because it can do really well on your synthetic data, but then when you actually do it on the real data, it's complete crap. So I've run into that before, where even especially when using it for if you have more than one right answer, and the right answer depends on who's asking the question. So more of a kind of RAG stuff where I need information about you to answer the question. You need synthetic data for your, if you're doing few shots, right? If you're putting examples in the prompt, you've got to have something synthesized, because you can't use a real one because the real answer may be different from person to person. And so you can't ask a real question and put in a real answer, because the model will say, aha, you gave me the answer to this question already. I'm just going to return that. And that created a wicked bug on our side. But synthesized data would not have found that. It's actually, okay, here's what it's actually supposed to be, and is it actually correct? So synthetic data can get you far, but there's sometimes when it's just, I need to make sure it's actually going to do what I expect it to do. But, and again, and those decisions are data science skills that you don't have. As a software developer who's not a data scientist, that you're going to have to bone up on, like, how does this work and why does it work? Like I said, I don't have enough time to get into to teach you how to do this. Like, I'm just warning you, you're going to need to know this if you're doing an AI project. You're going to need to know how to gather data, because if you don't work at a place with data scientists, nobody else knows how to do it either. So whoever's, if you've got a business analyst or a business owner who's coming up with here's what you need to do, it's like, well, where are we getting our data? Have you considered data gathering? Because they probably haven't. All right, the AI is the future, it's great, put it in. Cool, well, I need data. Do you have a question?
Yeah. Do you think a lot of this is assuming the fact that we're not just all going to be using off-the-shelf LLMs? We're going to want to fine-tune our models.
Oh no, this is using an off-the-shelf LLM.
Okay.
That's why I said we're not getting into like fine-tuning, and we're not even getting into RAG, because RAG is a whole other set of testing, right? Just consuming a model, right? A general purpose model, right? If you are using an LLM that is not a general purpose LLM, you may not have to do as much data gathering. That's their problem, right? But when I talk about AI today, right? This is, you're using Anthropic, you're using Google, you're using X, you're using OpenAI, and you're using a general purpose LLM that can answer in various ways. It has a lot of information besides the information you want it to have, so it will construct answers all on its own. Like we saw today, we were looking through some stuff and found another problem. It's like, oh yes, that looks like the right answer. And like, go check and say, oh, this is not the right answer. It made it up, right? It looks really good. It would pass for somebody, for a different policy. This would be correct data, but for the one that we sent it is the wrong data. So, it also depends, right? Do you have an expert system? Or do you have something that's interactive? Interactive, you can be a little loosey-goosey about it. Expert system, can't be. Which again, so it's how you do this, how much you have to do it, and what you have to consider, and where you can get your data from depends on your implementation. But in my experience, right, you have to tell the LLM how to do what you want it to do, right? That's the prompt engineering. And you will iterate on your prompt engineering until it gets it right. Because if you have 1,000 questions it has to answer, you have to ask it all 1,000 a number of times to find out if your prompt is going to work for every one of the 1,000 questions. Because, again, it can make something that looks like it's correct, but it's not. LLMs make up stuff all the time. It's called hallucinations. Any other questions about that? Yeah?
How much can you constrain the answer coming back with your prompt? Like, how much can you make this less of a problem?
You can make it much less of a problem, but you cannot constrain the LLM. Right? The LLM will do what the LLM does. Right? You can tell it never. Right? We have tests that say, as an insurance adjuster, you should never use the word damages. Damages is a legal term, right? Talking about monies that are owed to someone, as opposed to damage, which is something that happened to your possession or your house or whatever, right? And you can tell, right, in the prompt, never, ever, ever use damages. Use damage, right? Here are the other words you can use. Do not ever use damages. Never, 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 ever. And then it just spits it out one out of 60 times, right?
It almost sounds like a lot of this is just introducing being comfortable with uncertainty in something like automated testing, acceptance testing. What is your bar for passes good enough, let's ship it? I don't know. I was thinking, well, we ship broken code all the time. We're not supposed to. We have automated tests.
We have automated tests that tell you, so hopefully you have automated tests that tell you something's broken and you make a conscious decision to ship it or not to ship it. But what you'll find is that you're going to have to come up with interesting ways to test whether something is correct or not. But all of that requires data, right? Because you're like, oh, I have 100 things in this database. If I go, if I query for the word that's in there, it will return the right answer, right? Because I know that here are one of the 5 things that can come back if I query for this thing in the database, because every time I query, it always returns the same results. If you do that exact same thing in an LLM, first of all, it won't come out with the exact text that you specified, depending on what you're doing. Expert systems can come back with exact text, but it may be capitalized different. Like there are different levels of exact that can come back. And if you're having it write any kind of text, right, it will say the same thing in a different way. So what you have to do when you're data gathering and in your we'll get into this a little bit more in the testing part, but you have to understand what's really important, right? And act like a data scientist, right? Data scientists never release models that are 100% accurate, right? They have an acceptable level of tolerance that I will allow this many false positives and this many false negatives, right? And you tune the model to reach that threshold. But they have the data to test it, right? Which is, as a software developer, I'm not used to doing. I'm not used to having to come up with a way to ask, or a way to prompt the model, right, to give my application input and verify my output, because I'm used to just, here's the in, here's the out, write a test. If I give you this, you give me that. It gets very different with AI. So, and I'm also not used to having to, like, I make assumptions like, I don't want to write 100 tests, right, for something that's going to work the same way every time. As long as I give it this input, I get that output. Here's the top, right? So if you've written a test, right, you can give it an infinite number of things, but let me go top bound, bottom bound, one over, one under, right, one right below, one right above, somewhere in the middle, and then random, right? When you have large things to test. Because in theory, right, it should react the same way. You're just making sure it's following the instructions that you gave it for regular code. AI doesn't work that way. And then, in my experience, what you'll find is you're going to have to really change what data you need based on what you're seeing in the real world results.
It's like testing non-deterministic versus non-deterministic.
Very, yes. That's exactly what it is, right?
Not like it is.
Yeah.
Very good.
Yeah. And I said, like, this is the thing that I didn't expect. I'm like, oh, I'm going to go build an AI application. Let's go. Here's what it's supposed to look like. Here's what it's supposed to do. Go, write it. Yeah, it's great. Ship it out there. And they're like, why is it saying this bullshit? Like, what? I don't know. Let me go look. oh, we didn't test that particular scenario. Some of it comes down to like understanding your subject matter. And then this will come up later, is that your subject matter can change. Yeah?
Wouldn't in many cases you just use the annotated trading data, pass it back into the model and test against?
But we didn't create the model. So yes, if you were building a model, yeah, you would say, I'm going to use 80% to build it, 20% to test it, right? That's the whole data science thing. But we don't have the data. We can't afford to run that test, right? Because if you look at any of the LLMs that are out there, right, they're using Common Crawl, which is 40 billion web pages. So we actually couldn't afford to run the test because it's expensive. Anything else? All right. So performance testing, right? This is another significant disruption. It's not a new piece, right? But it's going to change drastically. If you've run like load-based performance tests as part of pre-release, post-release, some sort of pipeline, you're likely focused on response times, resource utilization, right? All the things that matter to most applications. And you may solely rely on monitoring or performance tests quarterly, right? So sometimes like, I'll monitor it, and then like quarterly, I'll run the test to make sure that I'm going to meet my capacity needs for the next 3, 6, 9 months, whatever. So it's just an exercise that happens occasionally. When you use AI models, you need to start using data science level model validation techniques, right? Because all models have a certain level of accuracy. We just talked about this a bit. And generalized, right, for AI models, it can be affected by both the prompt, right, so the stuff you have control over, and the input text, stuff you don't have control over. Prompt changes between releases. So, if you're doing a release, I'm going to test it. It's always going to work in theory, right? There's a certain level of accuracy, but if you don't change the version, and depending on your provider, if they don't change anything other than the model, right? Because even if you say like, I am pinning to this model version, that doesn't mean nothing changed. That was a frightening wake up for me. But you can be fairly comfortable that if you don't change the model version you're using and you don't change the prompt text, it's going to work pretty much the same way. But input text is not that way. So that leads to monitoring, right? And the reason I say that is most of us who've done any kind of DevOps or Ops type stuff, right? There's your favorite Grafana. Tracking all the things that you're used to tracking, right? Memory, CPU, response time, all that kind of crazy nonsense. Depending on where you are and how good or bad your application, right? This just might be in a giant television all over the place. Either you're especially proud of it or especially worried. But you're still going to need to do this, right? You're still going to need to monitor response times. And all the same system capacity metrics you always did. But there are new metrics that you have to monitor. Like drift. If you've worked with data scientists, you've heard them mention model drift, and which is why they're constantly telling you they need live data to test it because of model drift. And what that means is that your model may have been fine in week 1, but something externally changed. And for a data science term, right, your cohort has changed. So when you create a model, right, when you were testing this stuff, so we went back to the whole data thing, right? If you collected data, right, the first thing you collect is here's the data I think we're going to have, right? And then you release it, and then that changes. Here's the data we actually have, right? So that's when you're building a model, here's what I'm going to train on, and then they're going to verify it after it goes live, right? So if you've got like a fraud model, which is I'm most familiar with, you release a change to the fraud model because you think you're going to get, based on the information you saw over the past 2 years, here's the lift you're going to get on catching fraud. But you still need to watch it for a week, a month, a quarter, to make sure it's still trending that way, because situations outside change, right? Fraudsters find new ways to do things. You may be identifying people as fraud, but they're not because your population has changed. It's the same thing for your LLM app, right? You may have people who use different language, right? So it's like, oh, here's the questions people ask. And then you start getting popular in another part of the country or another country, right? Where they speak English a little bit differently and they use different words. And the model doesn't respond as well, right? So sometimes adoption requires you to change everything. What we're used to, right, in monitoring is that the more people that use it, the more resources it uses, means I need more servers and great, all that kind of stuff. Super easy, super linear. You can create an equation that for every 1,000 users per hour I get, I need this much stuff. But unfortunately, as your user grows, right, you start identifying different cohorts of it reacts to these people this way and it reacts to those people that way. So you're going to have to monitor that stuff. Fortunately, right, it's all the same thing. It's the metrics that you're using. You will have to change your data, possibly, right? Because we found this when we went from one insurance carrier to another, is that their internal terminology, although the industry terminology is pretty static, internally, they may refer to it in different ways. So for like an insurance adjuster, most of them have, either they'll have templates that are created or that they've saved for here's what I do for this type of damage, and here's a letter for this type of damage, and here's a letter for this type of damage. And internally, they refer to it by the names of those documents. So instead of expecting them to say wear, tear, or actually, let's go with one more interesting. Damage was not caused by the water as a result of a storm-created opening, right? They just call it storm-created opening. So I'm denying you because of storm-created opening. Well, actually, if there's a storm-created opening, it shouldn't be denied. So the AI gets all confused. So you're like, whoa, that shouldn't be denied. Storm-created opening is why it's covered, not why it's not. But all they refer to it as is storm-created opening. And you don't find that out until you get a new set of users who use this terminology. Or you'll find them where they'll have someone else will call it something else. And now the AI's got to be adjusted so it understands what that means. And again, it may not be as crazy on your particular application, but it is something to monitor, right? You've got to constantly monitor drift, even though nothing changes, right? You've got to run performance tests, regularly run performance tests, even though nothing changed. You just got to run over time and track them, just like any other performance metric, right? So you're going to want to, if you've got this Grafana board, you're going to want to model drift somewhere, right? These tests that run once a day, or you're collecting data like what we do, so we just collect real live data and we run it through an evaluation and say, is this correct? We have different metrics that we use and score it and say, okay, what's getting better, what's getting worse? So we can track that because it's just going to change over time, right? Which is very different from what I'm used to and you're probably used to. Any questions about the resource tracking, all that type of stuff? Yeah.
Is there like a standard, I guess, or this model drift thing is new to me, so I'm just trying to...
Yeah, there are, and it's all in data science places, right? So it's one of those things that's like, when you were a developer, right, you didn't know what the people in operations were tracking, right? Yes, they're tracking metrics because those are proven metrics to track over time. So drift is something that people who make models like that is what they do, right? Like the pieces and that's what I'm really getting into, right? Is that there's these new things that you're going to have to learn if you're going to be making an AI application and you want to succeed, right? Because you can make an AI application that sucks and nobody's going to know, right? But if you want to make an AI application that's going to succeed and you're not going to have data scientists, you're going to have to pick up some of their tools so that you can be successful. Right. And that's, again, the main reason for this presentation is like, these are the things that I didn't know when I started my journey into AI. Right. It's like, oh, this works great. Why is it not working over here? We've just this new carrot stopped working. Or they just brought on 7 new adjusters and like now we're having performance problems. What is going on? Not CPU memory. We're having problems with these not giving the right answers. stuff I was just not ready for.
And has there been experiments to try to like feed the response back into AI to validate the response versus human intervention to limit the response to determine if it's correct or not?
So you can do chaining, right? So that would be like creating a chain, and that's the problem is, right? So yes, absolutely you can do that. But first thing you've got to do is you've got to be able to make sure that your validation tests are correct. All right, so that every time you add more AI into it, right, there's more things you have to test. So, because the answer, like, I've got this before, is like, just throw more AI at it. Well, cool. But that's another prompt, right? And it too, right? As the model answers change, you're like, oh, well, this is actually still correct, but my model scored it as bad. So you absolutely can do that, right? So you could either have human input, right? Supervised input, and give it feedback, which is what everybody wants, is you want supervised human feedback, which always makes models better. But that also, like, now you've got the user having to like fix things, and that may or may not work for your application, right? That's why every time you interact with something that has a model, they've got a thumbs up or thumbs down, right? This was wrong, and they're actually tracking that. Okay, this is wrong, now we're gonna look at it. Why was it wrong? But for when you get the answer back, you say, well, tell me what's wrong with it, and you can feed it back. That's something you can absolutely do. But again, this is another model prompt. So now you're rerunning it, and you're going to have to tune it for that as well, tune your prompt.
When it's wrong, are you scolding it? Or is there like an API endpoint that you're saying this was bad or something like that?
So what we do, right, is manually or in an automated fashion, we go and we grade the results. It's more manual now because the grading, again, it's another model, so we're tuning the grading. Difficult for us, but maybe easier for other people's projects, because we're having to look at, like, did this piece of text come out of this 100 pages of stuff? And sometimes they'll say yes, absolutely, when it didn't, and we're having to tune why it's wrong. So we're not looking at doing an automated fashion today, but if we can get the grading good enough, right? So we're gonna use the grading to adjust our prompts for the generation. But if they get good enough, then you just feed it back, right? Because it also tells us here's the grade and here's why I graded it that way. So our plan, right, is to create that feedback loop internally of like, this isn't good enough. Regenerate it. Here's what's wrong. But that's a different prompt, right? And so it sounds like it's super easy to solve this problem. Just have the AI tell it what was wrong, feed it back in and tell it it's right. But it's another prompt that you have to develop and manage and iterate and test, right? So all these things won't stop you from having to do the rest, right? Every time you try and solve a problem inside the system with AI, you're now adding more data you have to capture. Because now it's like, oh, I need to capture the data plus the feedback and make sure that it's doing the feedback correctly. Right? It said, oh, here's the response, here's the problem, and you did it again. Did you actually fix the problem? So how do you actually figure out if you fixed the problem? Now you've got another model that's got to grade that, right? Yeah, it seems simple, right? When you think, oh man, we'll just do this, and then you realize that, oh, there's a lot of work in doing that. Yeah, question?
I might be a little confused here.
Sure.
Right? But
I wouldn't be.
In this scenario,
Yeah.
are we feeding data, right, to a cloud-like service that is sort of like, let's just say, scikit-learn or ML.net, that I am training like a new model?
No.
Right? Or no?
No.
Because
No, we're talking about you have a model, right? So
okay.
you're using a model as a service. So you're using OpenAI or Anthropic or Google or X, some large language model, and you're sending it prompts.
Oh, you're sending your prompts?
Yes.
Oh,
So
okay.
you have an application, like most people, when they think I'm doing AI and we don't have a data science team, which is going to become more and more and more prevalent, right? Because it's like there's all this stuff we can be doing, and it doesn't require data scientists, right? That's how everybody feels about it. And your application may not need, like, you might be able to get to the threshold that you need to get for, final success without having data scientists. In my world, that's not going to be true, At some point, right, I'm going to have to get a team of data scientists, but that's when I'm making a lot more money than I am now.
Okay, so I might not have been, okay.
Yeah, so it's more, yeah, so I'm not, this is not an ML ops talk or an LLM ops talk, right? That's a whole separate thing.
Yeah.
The reason that I brought up the life cycle, the LLM, the model life cycle is because as software developers, we never knew it existed, and we don't know what it's made of, but now we're going to be responsible for it. Because I'm going to add, my boss is going to say, we want to AI this thing. We've got to be able to put on there investors and whatever, right? It can be frighteningly easy to raise money if you use LLMs in today's climate, anyway. But the reality, right, is that AI that exists today can make certain business processes better or make them just as good but less expensive. Right, so there's a lot of pressure. Well, there's some pressure today. There's going to be a lot of pressure later as we go along that we need to put this in there because I need to make this better or I need to cut costs. The same reason people moved to the cloud, right? Moving to the cloud didn't make it better in the beginning. It just cost less, right?
Okay.
Any other questions? Yeah.
Do you implement any type of caching at all for, I guess you talk about having multiple responses, from a single request, and if you can confirm that there is a successful request, and we know that there's every time that we send a request off, it is expensive.
So in my system, it is not that, like, the applicant, yes, could you do that? Sure, you can put caching in front of anything. In my use case, no. Because the likelihood that you're going to have the same policy and the same denial item and reason is so low, right? You just have to have it in cache for months. And that's a lot of cache, by the way. So, yeah, I mean, at some point you've tried to find a way to cache anything to reduce costs and speed things up. But that's not something that I can do. But again, you're still going to have, whether it's caching or not, you're still going to have to build the application, and it's still going to have to come up with the answers, and they're still going to have to be right. And if you're building a chatbot, the last thing you want is for it to say the same thing every time. Right? So expert systems, you want it to always say the same thing. Conversational systems, you don't, because if it just says the same thing, it thinks you're stupid. Right? Oh, you're just copying and pasting this answer. You can't even think for yourself, kind of stuff. So if you're building a customer service bot, you don't want it to do that. You want it to explain it a different way and have context. I mean, honestly, with a chat bot, you're going to have the history, so it'll never be the same. So, yeah, question?
Do you think if I maybe wanted to add more value to myself as a developer, should I take a data science course? Like, would it be in my interest to do that?
I would say first place to start is prompt engineering.
You said prompt engineering? Okay.
So prompt engineering is like how to, basically specifically, you're learning how to ask the AI questions and what to do, right? Like, what's an effective way to write a prompt such that the AI does what I want it to do? Right, that would be the first step. Once you get past there, like if you're really good at getting ChatGPT to answer it correctly the right way the first time, you're probably most of the way there. On different subjects, you're probably most of the way there on prompt engineering. I'd say after that is, start understanding how to test against it. But there are data science courses, right? There aren't a lot of free resources I could find. AI Plus is not all free. There's some stuff that might be useful for this, but when I was first doing AI stuff, right, it's not super expensive. And they have, like, if you were a math geek like me, like, you could go retake your linear algebra class. You could, all the stuff that you forgot that has to do with models and all that type of stuff. But they also have very beginning stuff, like how to interact with an LLM. It's actually, I learned a lot, and it worked really well, and the instructors were really good. But I have a math background, so I don't know, like, your mileage may differ. There's mlops.org, ml-ops.org. And they have some stuff there to talk more about, like, I don't know what drift is, right? So MLOps will talk about, like, what is drift and how can you track it, things like that. And NVIDIA, somebody brought up NVIDIA, right? There is actually a really good, they have some really good information on LLM Ops techniques. So, like I said, I couldn't find a ton of stuff, but if you really want to get into the AI stuff, there's probably other things that are out there, and some of them might be better than AI Plus. But I really got into AI Plus. There's also, if you want other things, they also have like a ODSC, the Open Data Science Consortium. They have a conference and they do like boot camps. Which after taking the courses, the boot camp didn't help me. But if you're not going to take all the courses, the boot camp might. And it was an interesting conference for just kind of AI folks. I learned a lot, but I don't know if you would. And they have a whole section on the ML Ops side, so that's where I started getting tuned into the like, oh crap, like drift. And I was like, oh yeah, those data scientist guys did it, but now my app is going to drift too. Crap. Yeah.
So I've gone through the Google introduction to ML long
Sure.
before LLM was a thing. If you've done the same, did you find there was much transference with regard to learn the pipeline, learn how to train your own model, transference from that to this new world of LLM Ops, ML Ops?
So on the LLM side, it's just more expensive. Like, because originally, right, it's like, looking for what to do is, trying to find an idea that you can build a company off of using AI, right? Oh, like, let's host models. There's a bunch of models. I mean, back then it was just, there was like OpenAI, and then that was it. And Hugging Face, right? If you know what Hugging Face is. And Hugging Face was crappy and slow and expensive. And we're like, well, let's just find some of the really popular ones and we'll just host those. And we'll charge people like a regular normal amount of money. Problem being is that you can't get compute time, right? You just can't get TPU or GPU compute time on any of the platforms because OpenAI and Anthropic are buying it all, right? There are no GPUs out there. It's gotten back to like, oh, crypto's dead. We can finally get a video game running on our computer, and then here comes AI. Like, no, they're stealing my GPUs. But yeah, that was the problem we ran into. Is like you could get a crappy one that you couldn't train a real model on. Like you could follow an exercise, right? And if you want to do like that type of stuff, machine learning, Google has a bunch of stuff that's actually pretty good.
Yeah.
And there are other things that you can do that for, right? Start learning how to use Python, start using PyTorch and like all this kind of stuff. You can do all of that. The problem being is that when you start getting into larger models like LLMs, it costs tens of thousands, if not millions of dollars to train a decent model. And 20% of that is just the testing. So it's analogous. The whole process is basically the same. It's just, the number of parameters is in the billions, right? As opposed to like millions of parameters that you get for a really decent ML model.
But if you take a basic ML course, you're at least getting the basic data science language, and that's applicable regardless.
Yeah.
So, okay.
Yeah, and the idea of like the stuff that you're using to train it is also stuff you're going to use to test it, and so if you've done that, like you have an idea of what. Well, let me back that up. They'll tell you about it, but like until you actually like are responsible for a model from cradle to grave, right? It's there's probably a lot of things that they're not talking about because they only have like an hour to tell you about it, and there's like a billion situations that could come up with your particular model. Any questions? Cool, thanks. I'm over 18 minutes. Ooh. I apologize. It's your turn, Josh.
Sweet. Thank you. Let me take the
Microphone.
You rock, Adam. That was awesome. let's give away some stuff. So who here is interested in the JetBrains license? 1 year JetBrains license, going, gone. Okay. And then who's here?
No one else wants it?
Yeah.
Got one, yeah.
Yeah, a lot. I know a lot of the people have already scraped. Who's here is interested in the 1 month Symphony Cast license?
What is that?
Symphony Cast, a Symphony framework for PHP, but there's also JavaScript. It's basically a bunch of tutorials, but they're like exclusive tutorials that have like all the source code and like
It's like
you know.
it's like Linda. Well, I guess it's LinkedIn Learning. It's like LinkedIn Learning for the Symphony framework taught by experts that are really, really, really good at it, paid by Symphony to do it.
Yeah. So anyone interested?
You got one?
Yeah. Take it? Okay, cool. Then just get me your email here at the end. Same. I think I might have yours, but just give it to me again here.
I got to be a writer again. That was awesome.
Couple of things. So next month, we have somebody coming from the UK to speak, which is awesome. And that's what's awesome about the, open source community or programmer community in general is like, he's like, I'm here for a conference and I saw your group on Meetup. And I'm like, that's so awesome. You know what I mean? In fact, when I went to Portland, I was at a conference and on Meetup, I saw something about B-sides happening on Meetup so I literally went to 2 conferences at once just because I just bumped into it. Meetup.com is, even though people complain about Meetup.com costing money, it's still awesome. I mean, it does connect people. So anyway, he's going to be speaking about API. It's called API is Your UI, which is an interesting talk. The abstract will be, it's already up on our Discord. If you don't have our Discord, in fact, I was just told that our Discord link is not in the Meetup details, which I just updated. So now in our Meetup details, there is a link there to join the Discord. There's a handful of us in there. Rick, get in there. You should be in there. Everybody hop in. It's a great place to share ideas, memes, or just chit chat and bounce ideas off of each other. So do that as well. And let's see, there was one, I know. On LinkedIn, Aristocrat hit me up about a job opening that they have. So Aristocrat, they are looking to fill, I'll have to pull it up real quick. I've known this guy I've been actually trying to get them to sponsor our user group again. So I'm trying to see if I can I'll do you a favor, you do me a favor. Aristocrat.
Oh.
Yeah.
This is really cool.
So
this is like a job on the system?
yeah, so the the job title is slave laborer. No, I'm joking. It's senior software engineer, and it looks like they're doing a mix between Laravel and
Built on a Symphony framework.
so PHP basically, which is why we probably got reached out to. But anyway, if you're interested in that, let me know, and I'll send you the details on that. But figured I should shout them out. And thank you for everybody that came out today. And we'll probably head over to PTs a little bit, but we have some time to hang out here for 30 minutes or so. We kind of wrapped up a little early. So, cool. Thanks, guys.